Do you know about Timezones DST, UTC, and a Webex environment? Hi, my name is DJ, and I'm a technical solutions architect at Cisco. And I'm going to tell you all about that, and it's not as difficult as you think. So first, let's take a look at time zones. Time zones are areas where we use similar, uniform standard time. And that is important for business reasons, social reasons, and commercial reasons. And they are typically defined in computers, in phones, in systems applications. Examples are EST, Eastern Standard Time, where New York is, and, for example, Central European Time, which is where I'm located. And that is causing a challenge, right? There is Karen. Karen is an AI-generated person that lives in New York in Eastern Standard Time. And I am DJ, by me, and I'm a naturally created person living in Amsterdam in Central European Time. So Karen says, let's call at 5 o'clock, 5 p.m. What is that? 1700 hours? Yes. But is that 5 o'clock Karen time, which is 11 p.m., 11 o'clock in the evening, my time? Or is it 5 o'clock my time, which is 11 o'clock in the morning, Karen time? That is a challenge, right? But we're human, so we can talk, we can explain, and then we can make a decision. So we will meet at the same time. Computers are very different. What if there was a solution? There is. It's called Universal Coordinated Time. And that is not a standard, not a time zone, even though it happens to be the same as GMT winter time. So it's a standard to display or store time. If you put UTC in a map, right there, it sits in the middle, and at the top you see the UTC offsets. If you look at PST, which is Pacific Standard Time, you will notice that it is UTC minus 8 hours. CET is UTC plus 1 hour. So the solution to the previous problem is that Karen will say, let's call at 4 o'clock UTC. Great. I mean, I know when that is, and she knows. Well, does she? So 4 o'clock UTC in the EST time zone. EST is UTC minus 5, so it should be 11 o'clock. And I'm thinking CET is UTC plus 1, so it should be 5 o'clock. And we will talk at the right time. Wow. But we don't talk like that. And what happens if you look at the message in the Webex client? So I write a message in CET time zone in the winter, and in the message I put the actual time as text. What happens? The system stores this message as 1:44. So I've written the message at 2:44. It is stored at 1:44. If Karen looks at this message in Eastern Standard Time, which is UTC minus 5, so that means 1 o'clock minus 5 hours is 8:44. So she will see this message with the timestamp 8:44, which is right, because EST time zone 8:44 is exactly when I wrote the message. So written at 2:44, stored as 1:44, and in another time zone displayed as 8:44. The message date and time shown in the client is a conversion of UTC to your time zone. So written at 2:44 CET, stored as 1:44 UTC, and displayed as 8:44 EST. Quiz. Karen responds after exactly 1 minute and says, "Thanks for this wonderful information." So how is this stored? Well, I can tell you it's not stored as A or D. Now why? Because we store information UTC. We don't store it as a time zone. And it's not 2:45, but 1:45, right? If you write a message at 8:45 EST, the offset is 5 hours, so 8:45 plus 5 hours is 1:45. So stored as 1:45, and in my client displayed as 2:45, exactly 1 minute after my previous message. Cool, right? So if I capture all messages in the Webex platform and I say I want from all the messages from February 25th, from midnight to midnight. Cool. If Karen would run that script, it would actually capture messages from February 24th, 7 p.m. until February 25th, 7 p.m. because she is in a different time zone. And UTC time does not match the time in EST, right? That's where the offset counts. If I would do the same thing, you see it slightly the other way around. If I wanted to capture all messages locally, right? February 25th, all messages, I would have to capture UTC February 24th, 11 p.m. until February 25th, 11 p.m. This can be confusing. What confusing, you said? Here we have daylight savings time, which is not a time zone, but we call it summertime. DST. This will confuse things even more. And why? Because some countries use DST and some don't. But what happens in the summer? In the summer, you spring forward 1 hour. So clock goes forward 1 hour, which means you can sleep shorter. That's not good. In the winter, the clock falls back 1 hour. So you can sleep longer, which is good. But the time changes. However, at the end of the day, you'll see that the time offset between CE, ST, and UTC went up with 1 hour. But the same thing applies to the difference between UTC and EST, which is now -4 instead of -5 hours. The result is there's a time difference of 6 hours, just like before. That's a good thing. So which countries support DST? Well, here's the list. And as you can see in the US, there is a few states that don't use DST, like Arizona. Therefore, they're not in the middle list. When do we change from summer to winter time? Mostly on Sunday, basically. So UTC to local time is UTC plus time zone offset plus DST offset, all defined by the operating system. So if we look at Pacific Standard Time, California, that is UTC -8. And in the summer, it's UTC -7. Compare that with CET, which in the winter is UTC +1, and in the summer, UTC +2. To make things easier, as we continue to do, we changed the name. So Pacific Standard Time in the winter becomes Pacific Daylight Time in the summer. And Central European Time becomes Central European Summer Time. Isn't that lovely? By the way, PST is Pacific Standard Time, not Pacific Summer Time. Even though the Python programming language calls it different. So remember, the next time you're at a party or a barbecue with family or friends, tell them all about DST, UTC, offsets. I mean, they'll love it. So what else is there to say about summer and winter time? It's the date where you change from summer to winter time. The interesting thing is that there is a difference between when, for example, the US changes and Europe. And as a result of that, there is a period of 2 weeks where the time difference between the US and Europe goes back 1 hour. And that means between EST and CET, we go back from 6 hours to 5 hours. When Europe changes to summertime, that goes back to 6 hours. Same thing in the winter. There's 1 week where Europe switches to wintertime earlier, and we have 1 week with an hour less time difference between the US and Europe. Python. How does Python deal with that and with DST? So as an example, I created a Webex space archive script. So it's a Python script. You can configure that, run it, and it will extract all the messages from a Webex space, convert it to an HTML file, and you can configure it to do tons of things. Output text file as well, output JSON, download images or files or both or neither, sorting order, restrict by date, number of messages, etc. So this script downloads messages in UTC format. First, let's see how you can recognize a UTC time from a programmatic perspective. Well, it's actually quite simple. It has a Z in it. So whenever you see this, you know it is UTC. What is that other thing there? There's a T in the middle. The T is basically nothing but a separator between the date and time. So it's easy to see that's where the date stops and that's where the time starts. Cool. So in Python, how can you deal with the time zones and DST changes? You can use external libraries. You can use online services to get the right information, or you configure dates manually. That is what I have done. And as a result, you can see that the script outputs a JSON file if you want to, and it has the message date in UTC format. See, remember the Z? It outputs an HTML file with the real time, in this case CEST, because the message was written on April 8th. Text file has the same output with the same date. How do I configure that? So I thought I have 2 variables, DST start and stop. And what I configure is I basically say 2, second week, 7, Sunday, right? 1 is Monday, 7 is Sunday. The 3rd month, March. And closing the DST stop date is 1/7/11. That means the 1st Sunday of November. Awesome. The local time is UTC, which comes from the message, plus the time zone offset coming from the operating system, plus the DST offset coming from these variables. As you can see right there, for the European configuration, I added a parameter called last. First I used 4, but in certain months, as you can see right here, there's 1, 2, 3, 4, there's 5 Sundays. So that would actually use the wrong Sunday to switch to summertime. There's a few reference commands that you can run in Python to see how your system behaves and how it deals with your setup, your time zone. This is quite interesting because with the first command, it will output this if you're in CET time zone, or the other one if you're in Pacific time zone. The weird thing is that it uses the acronym for CET and it uses the full text for PST. I don't know why it does that. And it gets even weirder because it calls it Pacific Summer Time, whereas the acronym says Pacific Daylight Time. Quite interesting. The two commands following, you can run, and based on your local time zone, it will output either this or that. So the first one is a date in March, second one is a date in April, which is in the summer. And in the summer you will see that it outputs CEST and Pacific Summer Time. Another interesting thing here, based on your local time zone and a date, this command will tell you if DST is active. So if I would change this date to for example, 5, it would actually still be DST equals 1. If I would change it to 2 for February, the DST1 would change to 0. These are for your reference. You can test them and play with it. So what have we learned? UTC is a standard. It's not a time zone. We've learned that why it's important that messages or systems use UTC to store time and date, and what DST is, and how it's affected by DST dates and by different countries and different settings. Plus, what does that in Python and how can you deal with that? If there's any, well, thank you for your time, first of all. Please like it. Liking helps me to create more things like that. But what I also need from you is leave a comment and tell me what other topics, what other Webex development integration topics you would like to see explained. Maybe things like oAuth, maybe things like how to build great bots, just to name a few examples. So let me know, put something in the comments, and again, thanks for your time. Bye-bye.